welcome everyone to week 13 of the ARC Academy for Qlik, brought to you by ARC Analytics here. We are on week 3 of the strategy series, where we talk about advanced topics around performance, strategy, and planning, specifically when it comes to enterprise architecture as you consider your Qlik Sense and Qlik Cloud deployments. So recap on last week, on week 12, we talked a little bit about scripting strategy, where to put your scripts, where to put your logic, and the different components that exist within the Qlik Sense and the Qlik Cloud environments, whether you put them into QBD generators, whether you put them into QVS files, whether you even put that script just into the front end of an application, or maybe it's a low-code version, kind of like a data flow and something like that. So have a lot of options now of how you can partition the workload inside of Qlik, and it's important to consider those things as you look at enterprise scaling. So again, most of these things we're going to talk about here in the strategy series, and today's topic included, are they're more of your performance-based metrics. So these things have to do with larger data sets, larger data models, higher cardinality, maybe more faster loading times and things like that. So these are things that are going to require a little bit more thought, rather than if you're, maybe working with an Excel workbook or two. It doesn't really matter as much where you're putting some of the calculations or where you're putting the script or things like that. So today's workshop is going to cover the calculation strategy. And I originally called this the set analysis strategy session, but we were thinking about it, and it really makes more sense to call it calculation strategies. Where do you want the data calculated? And that's different than the logic in a couple ways. So we'll kind of walk through here a little bit about what we mean by that. And I'll start by saying that set analysis, going back to what it is and what it isn't, set analysis is the where clause of the front end. So you can think of this as, devices, or in this case, let's look at the example for sales. You can pull up a sum of sales, which is going to just sum all of your sales from your facts table, wherever sales exists. And then as you start to add in, you can see in the screenshot here, they add in different limiting factors. So give me where this is saying where the year is equal to 2015. The one below that is saying where it's equal to 2015 and 2016. And then we're looking at year and country and things like that. So it's where you're applying these filters. And you can imagine that in Qlik, when you have this dynamic capability of having features and selections and all of these different things to interact with each other, if every KPI on the dashboard has all of these very, very specific metrics around this, this corner is this country, and this one is this year, and this one is last week, your numbers will never change. Your user will make all these different selections, and they're still going to be left with a static dashboard because you architected it like that. You've locked all of these metrics into stone and are all stuck there. So you want to keep that in mind, that the same way you can have these as set analysis, you can have them as filters too. So that's item number 1 here, is the back versus the front end. Where do you put the set analysis? In 9 out of 10 cases, I try to put the flags in the back end. So in this case, instead of doing like year 2015, that's when I would be doing year, and I would do a variable of like current year or something, and the variable for the year would be set in the back end. So by moving things to the back end, you're letting the script handle the calculation, the load script, rather than the front end script where people are actually making these selections and doing state changes. Then you move into syntax. Is it easy to read? Is it easier to read in the back end or the front end? If you have this crazy set analysis in the front end that has 15 conditions, maybe it's a lot better to put it in the back end where you can join it into a table and it has its own thing, and then it joins back in, and then you just have a standard metric that's called sales by country over time in this unit, and it's a very specific thing by itself. You don't have it all living in the master item in the front end. Moving into complexity, how is it structured? So a lot of times people will do this where you have, say, sales, you make that a master item. Then you have another item called expenses. That's another master item. What people will then start to do is they start to make master items of other master master items, start daisy chaining them and nesting them together, where you can just as easily do that in the back end. And you have a little bit easier way of reading it out in a proceeding load or in the load editor, rather than having to go open each one of these master measures and see, kind of play whack-a-mole and figure out what other master measures is this item linked to. So how complex is it? And then the last but not least is the performance. And this is what the next slide will talk about. But in Qlik, and really in any tool, when you're doing comparisons, when you're saying, hey, give me the sum of sales where the year is equal to 2015, that whether the field is evaluating a literal string or a number will evaluate the formula much faster. And it doesn't make a big difference when you're talking about, again, one set analysis function. But if you're saying that it has multiple conditions that are complex, exclusionary across millions of records, and then say this wasn't a numeric value, it was a string value that was trying to match on someone's like address or something, it can make the front end very, very slow, and you have a lot more hindered latency there. So something to think about here as we move into the last slide before Austin takes it away. So again, set analysis, how it really works in the back end and in the front end is that this, whether you do it through the back end or the front end, what Qlik is doing is it's looking at each line row by row. Same thing whether you calculate in the back end or in the front end. It's looking at things really on a row by row basis. And the way Qlik sees things is it sees them as symbol tables. And these are really important because if you can convert something to a symbol table for Qlik, then it doesn't have to do it itself. So an example here is like region. Instead of it being 1 or 2, most people would have it as north or south. But if you have a region code, it's going to be much faster to do comparisons against. It's going to be much easier to do joins against. You have data quality issues. Maybe you're looking at another database. Region is spelled different. Maybe it's not case sensitive and things like that. So anytime you can kind of look at things on the symbol level, which would be numerical values preferred, but reducing complexity, moving things to the back end, you're going to increase your performance and comparison times will speed up. So that's what we got for the back end here, kind of going through the high level slides of how does calculation work, why it's important, and what you can do. So now I'm going to hand it over to Austin, and we're going to get a little inside look at what it looks like to structure some of this out.
So like JC was talking about, there's a few different ways of thinking about how to strategize where to do your calculations, right? Whether to offload that from the back end to the front end using set analysis, or to keep things in the load script in the back end, right? To basically run your calculations or your flags, or do the impetus of calculations and compute when the app reloads versus if it calculates things on the fly in the front end. And that's what it comes down to ultimately, is when we're talking about performance and reactivity, how quickly an app responds and all that. A lot of that, most of that probably comes down to how you create your metrics and where your logic or your calculations live. And so with set analysis, for example, here I have an ACT score, a score for an ACT exam that you take in high school. And on the right side, you can see that this is just an average of ACT scores across all my students, my fake auto-generated students in here. Whereas over here in this calculation, it's a similar number, but it is different. This actually is showing the same base calculation, an average of ACT score. This is showing me where student grade number is 12, right? So these are the ACT scores just for the seniors, the upperclassmen in the school. And so that, is basically me creating this calculation in the front end. If I were to do that in the back end, basically what that would be is me creating a separate table in the load script where I would load a key or whatever for student ID, and then I'm loading ACT score, and then I'm doing that sum or that average rather calculation grouped on that student ID or grouped on class number, right? 9, 10, 11, 12. And so I can either do that in the back end, and when I do that in the back end, it's available to me in the front end, but then it's not dynamic, right? It's basically going to I would basically have a calculation that's just ACT score for my upperclassmen, which can be good. But then if I wanted to have a toggle here or something like that to toggle between the other grades, 9, 10, 11, it becomes a little harder to do that. I'm basically committing to doing that in the back end. So I'm basically saying the compute happens when the app reloads, and the sacrifice there is that I get it out of the way, and then things run snappier, quicker, because there are fewer calculations as an end user of the dashboard, but I lose some of that reactivity. And then conversely, I could just load my raw data and not do a bunch of, aggregations, sums, counts, averages, and even more complex stuff than that. And I could just leave that to the front end here. So that would be like this example where I'm basically doing this calculation on the fly, right? So basically when this page renders, and then whenever I make selections and click on things, Qlik is going to re-evaluate this expression right here. And so every single selection I make, I'm using a little bit more of the brain power of Qlik, which in and of itself is not a bad thing. But when you have a large data model with a lot of different tables, or I have a sheet or a dashboard with a lot of different objects and a lot of different metrics using a lot of different calculations, it's going to become really sluggish after a while, right? And so that's where it becomes important to find that strategy. And usually the rule of thumb is if you have a large data model, just in general, the more things that you can calculate in the script is better, right? Because it's better to sacrifice the load time of a larger app, which is going to take longer to run anyways, which you would expect to take a long time to run. Better to have the calculations done there, and then the front end is a little snappier, which is good because when you have a lot of data that you're loading, those calculations become just slower and laggier. So you have a lot of calculations with a lot of data, it becomes slower and laggier. So if we can at least do the calculations up front when we reload the app, then the end user is not quite as bogged down by the latency there. So that's a really important facet when you have a large data model. You want to try and do that. Now, on the other side of the coin, it can be really useful to develop your applications quickly as a developer, right? And in that regard, it's really nice to be able to wireframe and test things out, test out calculations, and validate and verify numbers and make sure the numbers look right. That's where it's really nice to be able to use set analysis. So it's especially nice when you want to start developing your applications. You can quickly iterate on things. Let's try, this calculation with this grouping or this where clause, which is more or less how a set analysis acts. That's where it becomes really, really helpful for getting apps created quickly. And then after you have the logic created using set analysis, you can always then kind of move that logic to the back end, to the script, to kind of lock it in there. And then some other strategies we can think about here are, and then the other piece to consider here is just the general kind of dynamic or reactive nature of what you're trying to create. When we're trying to use things like variables and alternative measures and dimensions and things like that, it can be really useful to use that analysis to incorporate that reactivity into the dashboard. So like if I have a variable, for example, that is going to toggle certain columns that I'm using in my charts or my KPIs or what have you, that becomes basically impossible to deal with if most of your logic is in the back end. It becomes much more doable. It becomes doable when it's a little more open and you're relying more on set analysis in the front end, because with set analysis you can incorporate variables that users can update on the fly. And so when reactivity is especially important, and ideally for apps of medium or smaller sizes, then set analysis becomes really a really powerful tool. So at the end of the day, it becomes that balance of, well, you might need just that good mix of having a large app with a large data model, but also needing a good amount of reactiveness and dynamic, selection ability. And it's really just that finding that sweet spot of what calculations or metrics can I offload to the script side, and that I can basically calculate up front, for various groupings. And then what can I keep kind of open and dynamic, where I can use set analysis in the front end, such that I can iterate on it quickly as a developer, and I can also incorporate other things like variables and some more complex kind of features of set analysis in order to show the exact thing I want, without having to think through the whole trail of logic up front and or in the back end in the script. So that's really what it comes down to. It's a really important piece of creating an app because it has implications for speed of the snappiness of making selections and seeing things render. It has important implications for how long an app takes to load, which then has downstream effects for how often can I realistically load an app, how many times a day, and then how big is the app by the end of it, as that has licensing implications and other things like that. So all of that comes into play with where you choose to use, whether or not you choose to use set analysis or do it in the back end, and just your overall calculation strategy.
Thanks, Austin. All right, well, that wraps up week 13 in total and week 3 of the strategy series. So thanks for tuning in and join us next week.